Hello, y'all, and we are ready to do a warm-up. If we were in class today, I would be giving you this warm-up to do so that we could take a quiz. But lucky for you, we do not have a quiz today, right? So that's the good news. So let's look at this and just see if you remember everything. The second time I've taught it today, I just did the lesson and did not hit the record button, so hopefully this one's working. A prize company uses the following probability model. So we're gonna, the big word I want you to get with this is probability model, so that when you're faced with that word, you don't sit and say, oh, well, what do you mean a probability model? It's simply writing down, right, the random variable right? The random variable and the probability. This is like X, this is like Y. So first question, they gave you one. Is this a valid probability distribution? Explain why or why not. So if we add up all of our probabilities, 0.5 plus 0.4 plus 0.1, they equal 1. So yes, it is, because the probabilities add up to 1. There we go. Sketch a histogram. We want to be really good with our histograms by now. This takes us back to the fall, but they never go away. It's a great way to look. Oops. 0, 50, 100. And then this is the amount of money paid per winner. We want to be very good at labeling our axes, and then our probabilities went from 0.1 to 0.5. So 1, 2, 3, 4, 5. So over here we would label this probability of winning. All right? Okay. So of not getting any money, my probability is 50%. That's not so good, right? And remember, for our histogram, our boxes must have the same width and they must touch each other. 50 is 40%. That's not too bad, right? Pretend like I can make all mine the same size. And last but not least, we have $100. That's the one I want. And we gotta, okay, so remember, to qualify as a histogram, it has to be quantitative. Our boxes must have the same width on the bottom and they must all touch each other. Calculate and interpret probability that the money is greater than 50. So we would, let me go back up. I'm circling these so the box colors match. So if I look at it later, I can see. So greater than 50, okay. This is $50, so I would want anything greater than 50. So that is $100, and my chance of winning that is 0.1 or 10%. Find the expected value and explain what it tells you. So the expected value, we take the amount times each probability. So my expected value is 0 times 0.5 plus 50 times 0.4 plus 100 times 0.1. So type that into your calculator to practice, and that's 30. So you can expect to win. That means you can expect to win $30 per year in the, let me get a different color, long run, right? I made my word long because we know that if you buy one ticket, there is no way to win $30. You either win 0, 50, or 100. So in the long run, if you kept playing this, and let's say you played it for 20 years, if you were to add up all of your winnings and divide by 20, you should be at $30. That's your expected win. Okay, so remember, it's the long run. Really, if we looked at all the people who played, this is what we're talking about, big numbers. Okay, so now you hit pause and you do number 2 as a self quiz. I'll kind of help you get started. The random variable, what is the random variable? Well, it would be the dollar amount. And if you look at this, we have 25s, 15 10s, 10 15s, 5 20s, and 125. So therefore, that's 20, 35, 45, 51 total bills, right? So construct a probability distribution. You have one right up here to look at. So I am going to give you a minute. Actually, I'm just going to tell you to hit the pause button, and I'm going to put the key up so you can check it. So really hit the pause button and really go through and try to answer these questions. If we were in class together today, this is what your quiz would look like. It would be a problem like this. So let's make sure you can do it. So hit pause. I'll see you in a couple minutes. Okay, we're back. So let's look at what you did. So if we look at this, right, you had X. We could have 5, 10, 15, 20, or 25 bills. The probability of getting a bill, well, there's 20 5s, so 20 out of 51. I converted it to a decimal. 15 out of 51, 10, 5, and 1. Put them as decimals. Now, one thing I would do here very quickly is I would add these up. Now, you know it's going to add up to 1 because you constructed it. This is a good way to test yourself. If you were to add these up and they did not add up to 1, then you would know that something was wrong. Perhaps you typed something into your calculator. So it is a nice self-check. Our expected value, we simply take the variable times the probability. So 5 times 392, blah, 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 blah. And we get 1029. Then we're asked if a person is charged $5 to select one card from the box, is the game fair? Explain why or why not. Yes, the game is fair because it costs $5 to select one gift card and the expected value is 1029. At the very least, you will break even. Again, this is not if you buy one card, right? Everything for probability refers to the long run, so you would need to buy a lot of cards, okay? Or you look at the cards that everybody bought. This is a good example for you of how you would have to answer a question if you were taking a written test. So anyway, this is your warm-up. I'm going to close this video and start another one. You could take a little break and then we'll do the lesson for today. See you in a minute. Bye.